Our topic of discussion today is trigonometry. So with trigonometry, something that is extremely important for you to know is how to label the sides of your triangle, your hypotenuse, your opposite, and your adjacent, as well as knowing which represents your sine, which represents your cos, and which represents your tan. What I mean by representation is which ratio is represented by that specific identity, whether it's opposite over hypotenuse, adjacent over hypotenuse, or tan, which is opposite over adjacent. So let's have a look at that. So we've got SOH CAH TOA. Now the S represents sine, the C represents cos, and the T represents tan. So when we are dealing with sine, cos, and tan, the first thing that you should always do is label the sides of your triangle. That is the most important thing. If you don't label the sides of your triangle, you might end up using the wrong side. So let's start with identifying which is our hypotenuse. The hypotenuse is always the side located opposite your 90-degree symbol. The side opposite your 90-degree sign would represent your hypotenuse. So this is now your hypotenuse. In order for you to identify your opposite, that is the side that is opposite the angle theta, or whatever angle that you are focusing on. So this is going to be our opposite. And finally, the leftover side, or the third side, or another way of thinking about it is the side that is below theta. This represents your adjacent. So always remember that sine from SOH CAH TOA, SOH, meaning opposite over hypotenuse. Our cos, CAH, which is adjacent over hypotenuse. And TOA, T for tan, O for opposite, and A for adjacent. Now, I know most of you already know this. This is the basics, but there are some that still struggle with these basic concepts. So I would recommend, if you struggle with this, go back to maybe a grade 10 textbook and just have a look, read through it to see how do you label each side? How do you change your reference point? For example, if the angle that you are dealing with is not this one here in the corner, what if it is this one on top? So understand how to change your reference point. That will also become useful when you are dealing with 2- and 3-dimensional trigonometry. So I'm now going to change my reference point. So if I want to use this angle on top here, what is this angle? We know that all three interior angles of a triangle add up to 180 degrees, that being theta plus 90 plus, let's call this L, equals 180 degrees. If we were to solve for angle L, that is then going to be 90 minus theta. Now, this will become important later on when we deal with co-ratios, which is something that is frequently examined within grade 12. So this angle here now represents 90 minus theta. If we were to now try to identify our adjacent, our opposite, and our hypotenuse based on our new reference point, that angle of 90 minus theta, we do the exact same thing. So opposite the angle, so opposite 90 minus theta, that is the side down here. So this is now going to be our new opposite, whereas the angle under this, or the side under this angle, is now going to be our new adjacent, whereas our hypotenuse still remains the same because the 90-degree angle has not shifted. Okay, because that 90-degree angle is still in its original position, our hypotenuse remains the same. So it's going to be the exact same setup. If we're dealing with sine of 90 minus theta and we're using a triangle, it's going to be the exact same thing. It's going to be opposite over hypotenuse for sine. It's going to be adjacent over hypotenuse for cos, and it is going to be opposite over adjacent for tan. So that is important for you to be able to identify and for you to be able to write out. So let's move on to the next part. Something extremely important within trigonometry is your cast diagram. Now you have two different types of cast diagrams. You've got your positive angles, which move in an anti-clockwise direction, and you have your negative angles, which move in a clockwise direction. So keep in mind that anti-clockwise is this direction. Clockwise is down. Okay. Now, I'm not going to get into the details of the negative cast diagram as I don't want us to use up too much of time. There is a video on our YouTube channel whereby you can get an idea of how to convert your positive cast diagram to your negative cast diagram. I will share a link for that video later tonight so you can have a look at it. Now, something important when you are dealing with your positive angle cast diagram is each quadrant. So if you look at quadrant 1, which is from 0 degrees to 90 degrees, you can see that within quadrant 1, sine, cos, and tan are positive. Within quadrant 2, we have sine positive and cos and tan negative. So how do we remember which is supposed to be positive and which is supposed to be negative? It's based on this notation, CAST. So the letter represents which identity is positive within that quadrant. So if you look at A represents all, meaning that all of the identities are positive within quadrant 1. So sine is positive, cos is positive, and tan is positive within quadrant 1. If you look at quadrant 2, we've gotten a little S in the corner. That indicates that only sine is positive, whereas cos and tan are negative. If you look at quadrant 3, there's a little T in the corner, which indicates that only tan is positive, whereas sine and cos are negative. If you look at quadrant 4, we have C, which indicates that only cos is positive, whereas sine and tan are negative. Another important thing that we use our cast diagram for is reduction. So our reducing formula or our reduction formula is 90 minus theta, theta, and 360 plus theta. These three are extremely important. The first one, 360 plus theta, is something that is not frequently examined, but it is important to take note of in case it is examined. So this angle theta over here, this just indicates that if the angle is less than 90, you do not need to reduce it. The whole purpose of reducing an angle is to make it less than 90. If it is already less than 90, you can just leave it as is. Now this 90 minus theta at the bottom, this is a co-ratio or co-function, whichever you want to call it. Basically what a co-ratio or co-function is that it allows us to convert from sine to cos or cos to sine based on the fact that we are using a different reference point. That is the third angle of a triangle. We previously mentioned this when we started our session. So this 90 minus theta and 90 plus theta, that will become important when you look at past paper questions. Now, when we move into quadrant 2, we've got a reduction formula of 180 minus theta and 90 plus theta. The 90 plus theta, this is our co-ratio within quadrant 2. Within quadrant 3, our reduction formula is 180 plus theta, and within quadrant 4, our reduction formula is 360 minus theta. Now, the goal of this is to use them within simplifying trigonometric expressions, proving that the left-hand side is equal to the right-hand side, as well as to a certain degree within your cast diagram, and most importantly within your general solution. Now, general solution is something that a lot of students struggle with. So your cost diagram is used in general solution. So if you remember your cost diagram, you should not have an issue answering questions. Now, this cost diagram is not given to you within an exam, so I would highly recommend that you learn your cost diagram. When we do past paper questions, you'll take note that the cost diagram is used for majority of your questions. So let's move on to the next part. So next, let's discuss co-ratios. So to discuss co-ratios, I'm going to make the cost diagram visible as well so that we can use it. So let's have a look at the first one, sine of 90 minus theta. How do we simplify sine of 90 minus theta? So first question that we ask ourselves, what quadrant is sine of 90 minus theta in? We can see that it is in quadrant 1 based on this formula. 90 minus theta. So all you are now doing is matching that formula to the quadrant. So 90 minus theta is in quadrant 1. So we've now identified what quadrant it's in. Next, we need to ask ourselves, is it positive or negative within that specific quadrant? And as you can see, all are positive within quadrant 1. Therefore, this is going to be positive. Next, because we are dealing with a co-ratio, that 90 is going to convert this sine into cos, and we bring down theta. That is how we are able to get positive cos theta. Let's have a look at the next one. If we have cos of 90 minus theta, so exactly as we did before, step number 1, we ask ourselves, which quadrant is this in? So 90 minus theta, we match it to our cos diagram. As you can see, it is in quadrant 1. We know that cos is positive within quadrant 1. Therefore, we bring this positive sign, or we introduce this positive sign. Next, we ask ourselves, okay, we are dealing with a co-ratio, so this 90 is then going to convert that cos into sine, and we bring down theta. That is how we are able to get positive sine theta. So we'll have a look at the last two within quadrant 2. So if we are dealing with sine of 90 plus theta. So this is now in quadrant 2 based on the formula 90 plus theta. So we ask ourselves once again, question number 1, what quadrant is this in? We've identified it to be quadrant 2. Step number 2, we ask ourselves, is this positive or negative within quadrant 2? And we know that sine is positive within quadrant 2, therefore it's going to be a positive sign. We then know that because this is a co-ratio, it's going to convert the sine to a cos, and we bring down theta. So sine of 90 plus theta becomes positive cos. Now, please don't assume that all are going to be positive. As you will see with the last one, it is possible to have a negative value. So let's look at our last one. We've got cos of 90 plus theta. Question number 1, what quadrant is this in? We know that 90 plus theta is in quadrant 2. Next question, is this positive or negative in quadrant 2? We know that only sine is positive in quadrant 2, therefore cos is going to be negative. So something important that you should take note of is that the original identity, the original question, dictates whether the answer is going to be positive or negative. So because cos is an identity that is originally negative within quadrant 2, our answer will be negative even though sine is something that is positive. So because we're dealing with a co-ratio, that cos is then going to become a sine, and we bring down theta. So that is how we deal with co-ratios. Lastly, let us have a look at the important identities that we should know. Thereafter, we'll move on to past paper questions. So the three, or rather the two main identities that you should know are your identities of tan theta is equal to sine theta over cos theta. From there, you can square both sides to produce tan squared of theta over sine is equal to sine squared of theta over cos squared of theta. In addition to that, if you were to put 1 over tan theta. The reason that it becomes cos over sine is because, let's do it together. If we have 1 over tan theta, keep in mind it's 1 over. Now we substitute sine over cos theta. It's the same as saying 1 divided by sine theta over cos theta. And we can turn this into multiplication by flipping it over. That then becomes cos over sine. So instead of memorizing the whole long procedure, all you need to do is remember that because it's 1 over sine theta, you just flip the identity. So instead of having sine theta over cos theta, you will then have cos theta over sine theta. And something important to take note of, if you have sine of an angle, so let's say sine theta over, let's introduce a different angle, cos alpha. This cannot be equal to tan theta. The angles have to be the same in order for it to be equal to tan. If you have sine of 20 degrees over cos of 50 degrees, it stays as is. It cannot be converted to tan theta or tan of any angle. Next, we have cos squared theta plus sine squared theta equals 1. Now, something important to take note of is that cos theta plus sine theta is not equal to 1, even though cos squared theta plus sine squared theta is equal to 1. From that one identity, you can move cos squared theta to the other side or move sine squared theta to the other side in order to solve or isolate for which variable or which identity you want to, namely being sine squared theta or cos squared theta. Now, next up, we've got our compound angles. These are something that you should know. You don't have to memorize it, but you should know how to use it. So you should know how to expand it, meaning to go from the left side to the right side. And you should know how to simplify it by going from the right side to the left side. Something important to be able to identify these easily is to look out for the repetition of an angle. If you see an angle repeat itself twice, so if you see two angles repeat themselves twice, that is an indication of compound angle. That's the first thing to notice. As long as you see two angles repeating themselves, always think of compound angles. And lastly, we have our double angle formulas. Now, cos2 of an angle is what most students struggle with because they are not sure which one to substitute. My best advice is to practice. Over time, you'll see that you'll get used to it. You'll already know which to substitute. But when you are starting off, I would recommend looking at the question that you are dealing with, because keep in mind, in most cases, it's unique to the question. So sometimes you can see that if you were to substitute cos squared of A minus sine squared of A, instead of 1 minus 2 sine squared of A, you might not get the answer you were expecting or the answer that was intended for you to get. For example, let's say we have this particular question, cos of 2x over, let's make it cos x minus sine x equals cos x plus sine x. And if we are told to prove that the left-hand side is equal to the right-hand side, we now need to look at the question and carefully consider which identity are we going to substitute in place of cos 2x. Is it going to be the first, second, or third one? In this particular case, it is important. If you were to substitute 1 minus 2 sine squared of A or 2 cos squared of A minus 1, you might not get what you wanted. An indication of that is if you look at the question, they've got cos and they have sine. So that is an indication that you need to substitute an identity that also has cos and sine. If you had a question that only dealt with sine, then I would advise that it would be better to substitute the identity that only has sine. The same is true with cos. So if you were to simplify this, all you would do is substitute cos squared of x minus sine squared of x over cos x minus sine x. From here, because this is a difference of 2 squares, you can simplify this into cos x minus sine x and cos x plus sine x. And that would be all over cos x minus sine x. From there, this cancels this. And as you can see, we are left with the right-hand side. So it's important to be able to identify which identity you are going to use. So before we move on to past paper questions, if there's anyone that has any questions on what we've done, something that wasn't clear, or something that you'd like to ask, you're welcome to do so. You're more than welcome to unmute your mic and speak up, or if you're feeling shy to speak up, you are welcome to type your message in the chat box and I will attend to it. So there's a hand up. Let me just see. Kelly Ann, you've got your hand up. Do you have a question? If you have a question, you're welcome to unmute yourself. If you're not sure how to unmute yourself, you should see it looks like a microphone icon with a line through it. If there's a line through your icon, it means that you are muted. If you click on it, the line should disappear and you will become unmuted. Then there was one more student that had your hand up. If you have a question, you are welcome to ask now. Okay, so there is a few in the chat box. Please repeat the last part about double angles. Okay, with double angles, what I was saying earlier was when you were dealing with double angles, in certain questions, it is important to be able to identify which double angle you are meant to substitute. For example, let me just go back to the whiteboard. Give me a second. So you can see that we've got two main double angle formulas, right? Sine of 2a and cos of 2a. These are the two main ones, or the two that we are given in grade 12, right? So if you look at this, sine is a bit easier because it's only equal to one identity. So no matter what question you were dealing with, if you were given sine 2a, it's easier to deal with because you know you are only going to substitute that one identity. But if you are dealing with cos 2a, it now becomes slightly more tricky or more difficult to, I won't say difficult, but let's use the word tricky. It now becomes slightly more tricky for you because you now need to ask yourself, okay, I've got cos 2a in this question, and I need to substitute an identity for cos 2a. So which one am I going to use? Am I going to use cos squared of a minus sine squared of a? Or am I going to use 1 minus 2 sine squared of a? Or am I going to use 2 cos squared of a minus 1? Which one should I use? Now, practice is the best way to figure out which one you are going to use. If you practice these types of questions a lot, if you just look at the question, you automatically, with confidence, know which one you are supposed to use. But if you don't practice this, my advice would be just look at what question you were given. If you identify that your question has a mix of cos and sine, I would recommend using the first one. So I'll repeat that once more. If your question has a mixture of cos and sine. I would recommend using cos squared of A minus sine squared of A. If your question only has sine, then I would recommend using the second one, that being 1 minus 2 sine squared. If your question has only cos identities in it, I would recommend using the last one, 2 cos squared of A minus 1. So depending on what is given within your question, you can use the corresponding identity. And one more thing that I would like to mention on sine 2A, because it's straightforward, it's just sine 2A equals 2 sine A cos A. Sometimes they can give it to you in a form that does not look familiar and expect you to simplify it back into sine 2A. For example, if they were to give you sine or 4 sine A cos A. Now, if you look at that, it doesn't completely look like our right side. It does not 100% look like 2 sine A cos A, but it looks familiar. There's a bit of a familiarity between that and what the question is given. So I would recommend don't just specifically look for 2 sine A cos A. They might not give it to you within that form. They can expect you to use your algebra rules to simplify it. If you were to simplify this 2 can be broken up into 2, or this 4 rather can be broken up into 2 times 2, and then you can have sine A cos A. Now it looks familiar. This can then be simplified into 2 sine 2A. So always try to see what looks familiar or what you can try to link up. Once you see, okay, this looks familiar to an identity that I already know, 2 sine A cos A, but the only difference is that that is a 4 and I'm supposed to have a 2. So ask yourself, okay, if my question has 4 and I'm supposed to have 2, how do I turn that 4 into a 2? You can just 2 times 2 and then break it up. So just see what you are given and try to ask yourself, how do I turn this question into what I am familiar with? That's the easiest way to approach it. Everything within trig is just a repetition. Okay, then we've got, when we cross out a negative and a negative. The last example you just did. Okay, someone's querying the example. Let us go back to that example. The reason that I cancelled these 2 out in my example is because they are the same thing. So cos x minus sine x, and then at the bottom I have cos x minus sine x. They are the exact same thing, so I cancelled them out, which would only leave me with my second bracket of cos x plus sine x. All I was doing was proving that the left-hand side can be equal to the right-hand side, okay? Something important that I have seen quite often is, if you were given this x plus 1 over x, you cannot cancel out x and x. That is not allowed. The reason is because of this plus sign. The plus sign is basically locking x so that you can't cancel it out. You can only cancel when you are dealing with multiplication. For example, if you had this in brackets times x, then you could cancel this because they are 2 separate terms. X and x plus 1, they're kind of separate because you were dealing with multiplication. But if it was addition, you cannot cancel them out. It's the same thing with trig. If you had sine x plus cos x over cos x, you can't cancel these 2 out. It doesn't work like that because this cos x is linked to sine x. Okay, technically what this is if you were to separate it, it would be sine x over cos x plus cos x over cos x. Then you could cancel it out and be left with 1 plus sine x over tan x. So keep that in mind. It's quite important and it's something that you can mess up easily. So just give me a moment to go through the balance of the questions in the chat box. How did I expand cos squared of x minus sine squared of x? Okay, so I expanded cos squared of x minus sine squared of x using a factorization technique that you've learned in grade 10. That is the difference of two squares. So if you think back to what you did in grade 10, there were two different factorization methods that you learned. Difference of two squares and difference of two cubes. So you should be able to, hopefully you should know how to do that. If you don't, I would highly recommend going back to a grade 10 or 11 textbook and refreshing your memory. What I will do is I will share a grade 11 textbook in the group chat, so you can, if you need to go back. So all this is let's say you have a squared minus b squared. In order to simplify this, because it is a difference of two squares, you repeat it, but change the sign. So in one bracket you'll have positive, the other bracket you'll have negative. Cos squared of x minus sine squared of x. All you now do is in one bracket cos x sine x. In the other bracket cos x sine x. And change the signs. One bracket will get positive, one bracket will get negative. It's a difference of two squares. If you struggle with using or simplifying trig expressions using your algebra rules, what I would recommend is just changing them. So on the side of your paper, if you have this, right, cos squared of x minus sine squared of x. On the side of your paper, let one of the identities be a, let the other be b. So you can then say, okay, on the side of your paper, I have a squared minus b squared. What would I do in this particular situation? So do something that makes it easier for you to identify or easier for you to solve. Okay, that's the whole point of this. So let's say we are given cos 2x over cos x minus sine x equals cos x plus sine x. And our question is to prove that the left-hand side is equal to the right-hand side. So whenever we're doing such a question, we will always start on the side that looks most complicated. The reason being is that it's easier to factorize and to simplify and to break it up as opposed to building up. So if we were to start on the right, this side, what do? You just have cos x plus sine x. What can you actually do on that side? Whereas if you start on the left, you can see that this is an identity. You've got something to start with. You can do something, right? So we always start on the side that looks most complicated or the side that has more stuff. So we know that this cos 2x is an identity. Cos 2x is equal to cos squared of x minus sine squared of x. It's equal to 1 minus 2 sine squared x and 2 cos squared x minus 1. So it's equal to those three identities. Now, how do we know which identity we are supposed to use? So let's have a look. We have cos and sine. If we look at our left side, so I'm only now going to rewrite the left side. So I don't want you to focus on the right, only look at the left side. If you look at your left side, you've got cos and you've got sine. But let's look at this a bit closer. Does that not look quite similar to this first identity? Excluding the squared, they look quite similar, right? You've got cos minus sine, there you've got cos squared minus sine squared. So automatically you need to think, okay, that's kind of similar. Let me try and go with that and see where it takes me. If you use an identity and your question doesn't work out or you get stuck along the way, just try a different identity. Trial and error if you are not used to it. So let's substitute. We're now going to substitute this. So we're going to have cos squared x minus sine squared x all over cos x minus sine x. Now, if you look at this, you can say, okay, it's kind of looking correct to me because I know I'm supposed to end up with cos x plus sine x, right? And if you look at what I have so far, you can already see a difference of 2 squares. So you know some stuff is going to cancel out. I'm going to get rid of that denominator. So if you were to use your difference of 2 squares method, it's going to be cos x minus sine x and cos x plus sine x all over cos x minus sine x. And from here, you can see that cos x minus sine x and cos x minus sine x cancel one another out. Now you are left with cos x plus sine x, and that's it. As you can see, we have now proved that the left-hand side is in fact equal to the right-hand side. So all we needed to do was to be able to identify which is the correct identity out of the 3 that we know in order to use in this specific question, okay? If you struggle with memorizing the identities, don't stress or don't panic. Your question paper will have it. I think it's the very last question or the very last page. You have all of your identities. You've got your formulas there. The only thing that is extremely important that you need to be able to understand how to apply it, how to use it, and what's on it is your cost diagram. Your cost diagram is not on your question paper, but it is important. You will see when we do past papers, almost every question will use the cost diagram. So I highly recommend, first thing you need to do, if you do not understand your cost diagram, spend tonight, go through your cost diagram, go familiarize yourself with it, attempt a few questions on how to reduce, how to simplify, which quadrant is which. Go and familiarize yourself with that cost diagram. If you know your cost diagram, the rest is easy, you'll be fine. So let us start. So our first question, we've got question 5.1. Given that the square root of 13 sine x plus 3 is equal to 0. So this is important, this piece of information. Something important to take note of, whenever you are given an equation such as that, step number 1 should always be to simplify it such that you solve for sine x or cos x or tan x, whatever you are dealing with. So step number 1, solve for it. So we need to get rid of that positive 3 and that root 13. That's the whole point, okay? So simplify this such that it is sine x equals to something. The reason that we do that is because that will tell us which quadrant our x or our angle is in. Okay, now next we have x is an element of 90 degrees to 270 degrees. Now that means that our angle is in a single quadrant between 90 to 270. So let me draw my quadrants up here. So 0, 90, 180, 270, and 360. So they've stated that x is from 90, so meaning from here, all the way to 270. So that means that x is either in quadrant 2 or it's in quadrant 3. We are not sure as yet. They do that a lot of the time. They'll give you a range, or more specifically a domain, because keep in mind those are x values, right? So it would refer to a domain. So they give you a domain or some range of values, and you need to be able to identify between the 2 quadrants that I'm given, which quadrant is my angle in. So if you don't simplify this equation, you're not going to be able to identify which quadrant it's in. So this just gives you an area. This narrows it down. Okay, so next we have, without using a calculator, determine the value of sine of 360 plus x. So remember the first reduction formula I gave you, and I told you it's not frequently asked. Well, here it is. It's being asked right now. Then next we have tan x. So this would be slightly easier. Then next we have 180 plus x. So this is another reduction formula. So just from question 1 alone, you are already dealing with 2 questions that you are now going to make use of your cost diagram. So if you don't know your cost diagram, question 5.1.1 and 5.1.3 will be difficult for you. So that is why I mentioned previously, it is important to know your cost diagram. So step number 1, let us go and simplify that equation such that we have sine x equals to something. So that is our first step. Let's do that. So we were given the root of 13 sine x plus 3 equals 0. This is the equation that we were given. Now let us solve for sine x. All we're now going to do is move that positive 3 to the other side, making it negative 3. From there, we will then be able to divide both sides by the root of 13, and we finally have sine x is equal to negative 3 over the root of 13. Now, if you think back to when we first started our session, I took the time out to go through sine, cos, and tan. What are they equal to? The reason was because if you don't know what sine is equal to, you're not going to know what that negative 3 or that root 13 represent. So we know that sine of theta is equal to the opposite over the hypotenuse. So that means that this negative 3 represents our opposite, and this root 13 represents our hypotenuse. So we now have the opposite, which is our y value, and the hypotenuse. The only value that we are missing is x. We don't know what is our x value or our adjacent value. It's always going to be like that. They'll always give you something that's missing. They can give you y that's missing, or the hypotenuse that's missing, or x that's missing, but in most cases, it's always one thing that's missing. So before we even get to our missing side, before we even get to calculating that missing side, step number 1, we simplified our equation. Step number 2, we now need to identify which quadrant is this going to be in. Keep in mind that they've mentioned that x is an element from 90 degrees to 270 degrees, meaning that it's either in quadrant 2 or quadrant 3. So how are we now going to narrow it down? Let's think back to our cost diagram. So I'm going to redraw my cost diagram. Now, if you look at the cost diagram, you can see that in quadrant 2, sine is positive, and in quadrant 3, tan is positive, which means sine will be negative. Let's look at what we are given. We have sine x is equal to negative 3 over the root of 13. So our sine is equal to a negative value. So if we look at quadrant 2, sine is positive there, which means it's not possible for our angle to be within the second quadrant, because we have a negative value of sine and quadrant 2 is positive sine. So quadrant 2 is out. The only quadrant that's left is quadrant 3. That means that our angle, or more specifically, our triangle that we are going to draw, is going to be within quadrant 3, because that is the quadrant whereby sine is negative. So let us now draw our triangle. This is quadrant 3. We're going to draw our triangle. As you can see, our y value goes down, which means it's a negative y. And as you can see, our x value is on the left-hand side of the x-axis. So it's going to be a negative x value. It's important. Think of your functions. You've got your x-axis, your y-axis. On the right is positive x, on the left is negative x, on top is positive y, and at the bottom is negative y. That information is important. You'll see a bit later on within this question, whereby we are going to use Pythagoras to solve for x. We will then need to know, is this going to be positive or negative? But we'll have a look at that in a moment. So we had sine x equals to -3. That means this is our opposite, which is -3. You can even say y equals -3. Now we need to get our x value, which is unknown, and our hypotenuse value is the root of 13. Always remember that your hypotenuse can never ever be negative. Your hypotenuse is always a positive value. Okay, so let us now use Pythagoras to find the missing side. That missing side is x. So we're going to have our hypotenuse squared is equal to x squared plus y squared, and that is Pythagoras. From there, let us substitute our hypotenuse, which is the root of 13, don't forget to square, equals our x value, which is what we are calculating, so we leave it unknown, plus our y value, which is -3, and we square. Something that's important that will make you mess up if you do this wrong is if you just put this -3 squared, that is equal to -9. That is wrong. We need -3 all squared. So don't forget to put the entire thing into the bracket, especially when you put it on your calculator. I've seen so many times whereby students write the correct thing, but when they're dealing with their calculators, something takes over. Well, I don't know what happens, but they'll put something different on the calculator and get a different answer or wrong answer. Copy what is on your page. If you've got a bracket on your page, don't be lazy. Put the bracket on your calculator. If you put -3 squared on your calculator, it's going to give you -9. If you put -3 all squared, meaning you put the brackets, it will give you +9. There's a difference. So let us continue. The students that have sent you messages in the chat box, I have seen it pop up. I will attend to it in a moment. Just keep in mind that I cannot see the chat box while I'm on the whiteboard. So when I'm done with this question, I'll move over to the chat box and I will address your questions. So from here, we have the root of 13 squared. If you put that into your calculator, you'll end up with 13. This x squared is going to remain x squared because that is what we are trying to calculate. This -3 all squared, put that into your calculator with the brackets. That is then going to give you +9. From here, you can move everything to one side, giving you x squared equals 13 minus 9. And that is going to give you x squared equals 4. From here, square root both sides, you'll end up with x is equal to positive or -2. So how do you decide whether you are supposed to take the +2 value or the -2 value? In order to figure that out, we now go to our triangle. Let us have a look. Is our triangle, or more specifically, our x value of our triangle, is that in the positive x area on the right, or is that in the negative x area on the left? Our triangle is in the negative x area on the left. Therefore, we are going to choose the negative value. So here we can get rid of that positive sign and only put the negative sign. Okay, so we've now identified the missing side. Now, give me a second to have a look at the chats to see what's going on. Okay, Google, you have your hand up. Do you have a question? Spilangen Kosi, no, buddy, we are not going to do trig functions today, okay? Okay, then I see there's 3 people with your hands up. Gugu and Rabelani, you've got your hands up, and then Kelly Ann as well. Do you guys have questions that you need to ask, or you just, what's going on? Yes, yes, Gugu. Yes, Gugu.
Got the negative. Let me see. The -3. But I noticed that you transposed.
Yes, yes. So initially it was +3 on the left. I moved it over to the right side and ended up with -3. Does that resolve your query?
Yes.
Okay, perfect. Then Rabelani, you've got your hand up, buddy. What's going on? Okay, someone's asking, why is the triangle in quadrant 3? So let's go back to our question. Now, our question initially stated that our angle is in quadrant 2 or quadrant 3. They just gave us a general area. They weren't specific. So like if someone told you I buried gold on that street over there, they're not specific. It's somewhere on that street. How do you narrow it down? Now we buried gold either in quadrant 2 or we buried it in quadrant 3. We're not sure as yet, right? So we needed to use that equation of the root of 13 sine x plus 3 equals 0 in order to narrow it down. The way we narrow it down is if we end up with a positive value, that means that it could be in quadrant 1 or quadrant 2 because sine is positive within those quadrants. But keep in mind, we could not use quadrant 1 and we could not use quadrant 4. We were told that it's only in quadrant 2 or quadrant 3. So this is where it's positive sign. If we ended up with a negative value, that means it's going to be in quadrant 3, because keep in mind that tan is positive within quadrant 3, whereas sine and cos are negative within quadrant 3. So let's go back to where we simplified that particular equation. So after simplifying the equation, we ended up with -3 over the root of 13. Therefore, our value or our triangle is going to be within quadrant 3 because we ended up with negative sign. Okay. Now I'm going to try to speed through the balance of the questions because it's already past 6 o'clock and we're still busy with the first question. And I would like us to at least complete this entire question before we end today. So let's continue. We've now calculated our x value, we put in our y value, and we've got our hypotenuse. So let us now move over to our question paper. Our first question, sine of 360 plus x. So first thing we need to do is ask ourselves, what quadrant is sine of 360 plus x in? We know that sine of 360 plus x is within quadrant 1 and sine is positive in quadrant 1. Therefore, this is just going to be equal to sine x. Remember I told you your cost diagram is important, right? This is why. Now, from here, we were given the value of sine x. What was that? Let's see. Where was that? Okay, here, sine x, but keep in mind that our sine x is within quadrant 3, not within quadrant 1. So we're going to leave it there, okay? Because if we were to substitute sine x in here, that's going to give us a negative value. But our rule stated that sine of 360 plus x is quadrant 1, therefore it has to be positive. And it's only worth 2 marks. So we're now going to leave it there. We're not going to substitute -3 over the root of 13 because that would make it negative. Whereas our reduction formula specified it has to be positive because it is in quadrant 1. That 360 plus x indicates quadrant 1. So we're done. Question 5.1.1, that's it. We don't need to do anything else. Let's move on to question 5.1.2. So question 5.1.2 is not specific. If you notice, there's no reduction formula there, so it's not specific. We can now use our triangle within quadrant 3. So question 5.1.2, that is tan x. So let us now try to simplify. What is tan x equal to? Keep in mind that tan x, SOH CAH TOA, TOA, T-O-A, that means opposite over adjacent. Now, let's go and look. What is our opposite value? What is our adjacent value? Our opposite value, which is y equals -3, and our adjacent value is x equals -2. Even though both of those values are negative, you'll see that we will end up with a positive value. That then proves that tan is positive within quadrant 3. Okay, so that is question 2.1.2. Once we are done with question 5.1.3, I'll have a look at the chats for those that have sent you messages in. So please be patient. Next, we have question 5.1.3. We've got cos of 180 plus x. Now, something important, 180 plus x. We need to identify what quadrant is that in. So if you think back to our cost diagram, in quadrant 1, we had theta, 90 minus theta, and we had 360 plus theta. In quadrant 2, we had 180 minus theta. In quadrant 3, we had 180 plus theta, and within quadrant 4, we had 360 minus theta. Extremely important. You need to know that by head, okay? So question 5.1.3, cos of 180 plus x. Which quadrant is that in? If you look at the reduction formula in the question and the reduction formula in our cost diagram, you can clearly see that that is within quadrant 3. So we can now use the values from our triangle because the rule is specifying that it is within quadrant 3, as opposed to question 5.1.1, which was within quadrant 1. So we could not use that triangle. So let us attempt question 5.1.3. So we've got 5.1.3, cos of 180 plus x. We ask ourselves, what quadrant is that in? We know that 180 plus x refers to quadrant 3. Next, we ask ourselves, is cos positive or negative within quadrant 3? And we know that cos is negative within quadrant 3. So that is then going to be negative cos x. From there, we can substitute. So we bring down our negative, we can open a bracket, and we know that cos is equal to adjacent over hypotenuse. Our adjacent value, let's have a look at that. Our adjacent value is -2, whereas our hypotenuse value is the root of 13. So let's see, -2 over the root of 13. That is then going to give us +2 over the root of 13. But if you look at the mark allocation, the mark allocation is only for 2 marks, which means you'll get 1 mark for stating this negative sign. So your marks will come here, 1 mark for stating the negative sign and another mark for stating cos x. That's the nice thing about trigonometry. You get so many marks within one question. If you are simplifying a trig expression, each identity that you change or reduce, you get 1 mark. So because it's only 2 marks, 1 for the negative, 1 for cos x, I'm actually going to get rid of this because we no longer need it. We already have our marks, right? From that negative cos x. So that is question 5.1. determine the value of the following expression without using a calculator. So for this particular question, they've stated don't use a calculator, but to be honest, no one really checks, so you can use one if you want to, it doesn't really matter. So we've got cos of 90 plus theta. First thing that should pop out to you, that 90 plus theta, that is a co-ratio. So that cos is going to end up turning into a sine. Next, we've got sine of theta minus 180. So that theta minus 180, that is a negative angle. So we're going to use our negative cos diagram for that. Then we've got plus sine of negative theta, and that is also a negative reduction formula. So we're going to have to use our negative cos diagram. So let's write out our question, try to get our negative cos diagram, and then simplify that particular expression. So we had, let's see, cos of 90 plus theta all over sine of theta minus 180 plus 3 sine of negative theta. So step number 1, let us try and get our negative cos diagram. In order for you to get your negative cos diagram, all you need to do is multiply your positive cos diagram by negative. That's all it is. It's not that complicated, right? So we know that it goes quadrant 1 to quadrant 2 to quadrant 3 to quadrant 4. That's when we are going in the anti-clockwise direction, dealing with our positive cos diagram, our positive angles. When we are dealing with a negative cos diagram, we are going to go from quadrant 4 to quadrant 3 to quadrant 2 to quadrant 1. We're basically going in reverse, so it's this direction. Okay, so let's look at quadrant 1. Usually in quadrant 1, we've got theta and we've got 90 minus theta. If we want to try and get our negative angles, all we do is multiply this by negative. So it's going to become negative theta in this quadrant. Then we multiply this by negative. That is going to give us theta minus 90. So that is the first negative quadrant complete. This is quadrant 4 of our negative angles. Let's have a look at the next quadrant, quadrant 3. So to get quadrant 3, we're going to use quadrant 2 because that's the next one in line. We know that within quadrant 2, our reduction formula is 180 minus theta and 90 plus theta. All we now need to do is multiply this by a negative. So that is then going to become theta minus 180 and negative theta minus 90. So that is what we write within quadrant 3 of our negative cos diagram. Now, the next one is our positive quadrants or our positive cos diagrams, quadrant 3. Do you notice that we are using our positive cos diagram to get the negative cos diagram? When you are dealing with a negative cos diagram, keep in mind it moves in a clockwise direction. So it goes from quadrant 4 to quadrant 3 to quadrant 2 to quadrant 1. So you're going to use the material, or you're going to use the reduction formula from quadrant 1 to get quadrant 4. You're going to use the reduction formula from quadrant 2 to get quadrant 3. You're going to use the reduction formula from quadrant 3 to get quadrant 2. Then you're going to use the reduction formula from quadrant 4 to get quadrant 1. Okay, so just keep in mind of the order. You don't ever change the order. It always goes in order. When you're doing positive cos diagram, it's anti-clockwise, quadrant 1, quadrant 2, quadrant 3, quadrant 4. When you are doing your negative cos diagram, it's the reverse. It's going in a clockwise direction, meaning quadrant 4, quadrant 3, quadrant 2, quadrant 1 in reverse, okay? Now, let us use quadrant 3 in order to get our negative quadrant 2. So we know that within quadrant 3, we have 180 plus theta. If we multiply this by negative, we're going to end up with negative theta minus 180. So that's what I'm going to put in here. Then finally, we can now use our positive quadrant 4 in order to get our negative quadrant 1. So in quadrant 4, we have 360 minus theta. If we multiply that by negative, we're going to end up with theta minus 360. So in quadrant 1, we have theta minus 360. Now this is my negative cost diagram, okay? So that is what we are going to use. So let's try to answer this particular question. First up, we've got cos of 90 plus theta. Keep in mind, from your positive cost diagram, cos of 90 plus theta was in quadrant 2. So we ask ourselves, is cos positive or negative within quadrant 2? And we know that it is negative. Next, because we are dealing with a co-ratio, we're going to convert the cos to a sine. So this is going to become negative sine theta. Let's have a look at our denominator section. So our denominator, we've got sine of theta minus 180. Let's look at our negative cost diagram to try and identify which quadrant is theta minus 180. So as you can see, here's the quadrant, theta minus 180. We found it. And what quadrant is that? That is quadrant 3. Let us try to put in our cost so we can see whether it's going to be positive or negative. Now, in quadrant 3, we have tan t. So that means only tan is positive, whereas sine is going to be negative. That then means that we are now going to put negative sine theta in place of sine of theta minus 180. So this becomes minus sine theta plus 3. So we bring down that positive sign, we bring down that 3. Next, let us have a look at sine of negative theta. What is sine of negative theta going to become? So let us try to match it to our cost diagram, specifically the negative cost diagram. So as you can see, negative theta is the reduction formula within quadrant 4. And what is positive in quadrant 4? It is costs, but we have sine. So that then means that our sine of negative theta is going to become negative sine theta. That is it. All we needed to do was use our reduction formula to try and simplify the question. Next, we don't need our reduction formula anymore. The reduction, or more specifically, the cost diagram. The cost diagram is used for the first part in order to simplify and determine which quadrants and which signs our identities are going to have. From here, we can just simplify using algebra. So on top, we've got negative sine theta. At the bottom, we have minus sine theta. And 3 times negative sine theta becomes minus 3 sine theta. From here, we can add up our denominators because they are like terms. So that then becomes minus sine theta over negative sine theta minus 3 sine theta is going to become minus 4 sine theta. As you can see, negative cancels negative, sine theta cancels sine theta, and you are therefore left with positive 1 over 4. That is it. So step number 1, we needed to identify which quadrants our identities were in. Once we've identified which quadrants they were in using our CAST diagram, we were then able to determine whether it is positive or negative. From there, all we did was use algebra to simplify the expression. Now, let's have a look at question 5.3. 5.3 is a general solution question. The nice thing about question 5.3 is that they kind of factorized it for us. So if we wanted to, we can, well, not if we wanted to, that is the approach that we are going to take. So all we now need to do is separate it. If they didn't factorize it for us, meaning that it was originally a trinomial, we would then need to factorize it. And I know that that is something a lot of people struggle with. They have a hard time factorizing trinomials when it is in a trig format. If you are one of those people, I would recommend replacing the trig identity with a letter. So for example, if you have, let's say one day you come across a question that is, let's say sine squared of x minus sine x minus 20 equals to 0. And you now need to find the general solution of this particular question. Instead of going and sitting there and spending an hour looking at that question, trying to figure out where do I start? What do I do? I don't know what's going on here. Do something you're familiar with. You've been doing algebra since grade 1. Well, technically, yeah. Because if you think about it, 1 is technically a to the power 0, b to the power 0, c to the power 0, d to the power 0, and so on, right? So technically, algebra was always there. So we have been doing algebra for a very long time. So replace the sign with a letter from algebra. A squared minus a minus 20 equals to 0. Now all of a sudden, okay, I know how to do that. I'm familiar with this. So if I want to factorize it, it's just a minus 5 and a plus 4 equals 0. From there, you can bring in your sign once again. So then just replace that a with sign. And voila, we've factorized a trig trinomial without actually factorizing it. We've factorized the algebra part. Okay, so all you need to do is convert it to a form that you're familiar with. Once your brain sees something that you are used to, that you are familiar with, that you already know, you gain confidence and you then know what to do. So if you struggle with it, I recommend doing that. But if you're fine with the concept, then that's awesome. Just continue as you do. So we now have determined the general solution of the following equation. Cos x plus 2 sine x times 3 sine 2x minus 1. Now, if you look there, we've got sine 2x, which means we are going to use a double angle formula at a certain point. So what do we now do? How would we now simplify this type of question? It's as you would simplify a normal algebra factorization equation. If you have x minus 1 and x plus 2 equals 0, what do you normally do? You separate them. X minus 1 equals to 0 or x plus 2 equals to 0. So it's the exact same thing. We're going to separate the brackets and equate them to 0. Nothing's changed. We're doing the exact same thing we've always been doing. So let us now attempt this particular question. So we've got cos x plus 2 sine x, 3 sine 2x minus 1. Okay. So we had cos x plus 2 sine x into 3 sine of 2x minus 1 equals 0. We now need to find the general solution of that particular equation. Step number 1, as we do a normal equation, we are going to separate. So on the left, I'm going to have cos of x plus 2 sine x equals 0, or 3 sine 2 x minus 1 equals 0. Now, to make my life easier, I'm going to separate it. So for now, I'm going to ignore the right-hand side. I'm going to pretend as if it doesn't exist. I'm only going to deal with the left-hand side. But before I do that, let me move my left-hand side more to the left so I have enough space. I don't want to run out of space along the way. So let us look at this. Let us deal with this only for now. We'll have a look at the right-hand side a bit later. So if we look at this, we see that we have cos and sine. Now, if you think back to when we first started this session, we mentioned that sine and cos can turn into tan. That's the general direction that we are going to move in. We are now going to try to convert this cos and sine into tan. So I'm going to move 2 sine x. Actually, let me move cos to the other side. I'm going to keep 2 sine x on this side. I'm going to move cos to the other side, making it negative cos x. From there, I know that in order for me to convert this to tan, I need to have sine over cos. So what I'm now going to do is I'm going to divide both sides by negative cos x. So divide the side by negative cos x, divide the side by negative cos x, and I then have negative 2 tan x equals 1. Because sine over cos, that gives me tan. 2 divided by negative, that gives me negative 2. And then on the right-hand side, I've got negative divided by negative, that gives me positive. I've got cos divided by cos, that cancels out. So I'm just left with positive 1. From here, I'm going to divide both sides by negative 2. So to avoid having to rewrite it, I'm just going to move that negative 2 to the other side. So I've divided both sides by negative 2. Now, as you can see, I've got tan of x is equal to negative 1 over 2. Whether you say 1 over negative 2 or negative 1 over 2, it means the exact same thing. The negative is for the whole fraction, okay? So let us move on. From this point, what can we now do? What's our next step? So something important, we need to ask ourselves, what quadrants is tan negative? The reason being is because we have tan x equals to a negative answer. That is why we are asking ourselves which quadrant is tan negative in, because our answer is going to be in the quadrants whereby tan is negative. So let's have a look. Quadrant 1, everything is positive. Quadrant 2, sine is positive, therefore tan is negative. So our first answer is going to be in quadrant 2. Let's move on to quadrant 3. Quadrant 3, we know that tan is positive, so our answer is not going to be in quadrant 3. In the fourth quadrant, cos is the only one that is positive, which then means that tan is going to be negative. So from here, we know that our answers are going to be in quadrant 2 and quadrant 4. So we'll make a note of that. Quadrant 2. Skip some space to do our calculation, and then quadrant 4. That's where our answers are going to be. Now, before we even get to the quadrants, we need a reference angle. What are we going to use as our reference angle? We are going to use that equation tan x equals negative 1 over 2. But keep in mind, whenever you are calculating a reference angle, never ever use the negative. So let's calculate our reference angle. So our reference angle is going to be equal to x equals tan inverse of 1 over 2. That is our reference angle. In order for us to get rid of tan, we moved it to the other side, therefore making it tan inverse. If you don't know how to put tan inverse on your calculator, if you are using a sharp calculator, press Shift. Shift is the yellow button located on the top left-hand corner. Press Shift, then press tan. You'll see you'll get tan inverse. Now, why have I left out my negative sign? Why have I not put tan inverse of -1/2? As I've mentioned previously, we always leave out the negative sign when calculating a reference angle if there is one. Because we want a reference angle. We don't want to be dealing with a negative reference angle. It makes things complicated and we don't want to complicate life. Let's keep it simple, ignore it, pretend as if it's not there for now. This information is important. Always leave out the negative sign when calculating your reference angle. Okay, so let's move on. From here, we now know that our reference angle, so I'll denote it by reference angle instead of x. Our reference angle is now equal to, so let's put this onto our calculator. Press Shift, press tan, press 1/2, and you end up with 26.57. That is our reference angle, 26.57 degrees. This angle is extremely important. It's going to be used in all of our calculations in quadrant 2 and quadrant 4. So we've found our reference angle. Now let's find our solution. Let's find our general solution of x. So we've already discussed why we chose quadrant 2 and 4. The reason we chose quadrant 2 and 4 is because tan is negative in quadrant 2 and 4. If we ended up with tan of x equals to a positive value, we would have then used the quadrants whereby tan is positive, meaning quadrant 1 and quadrant 3. But because we ended up with a negative value, we are now going to use the quadrants whereby tan is negative, quadrant 2 and quadrant 4. So when we are calculating our general solution, we use our cast diagram for this part. Once you get to the quadrants, you need to use your cast diagram. Now, in quadrant 2, let's ask ourselves, what is our reduction formula in quadrant 2? We know that our reduction formula is 180 minus an angle. So instead of using theta, I'm just going to use that L to represent an angle. So because our reference angle, I used L. Okay, so I want to create that connection. Now, our reduction formula is 180 minus an angle in quadrant 2. And don't forget, because this is general solution, we have to put plus k times our period. Keep in mind that the period of tan is 180 degrees. If we were dealing with cos or sine, we would use k times 360. But because we're dealing with tan, we now use k times 180. Okay, so from here, let us substitute. We now need to substitute this reference angle in place of L and then solve for x. So x is now equal to 180 minus 26.57 plus k times 180. From here, we can put that into our calculator, 180 minus 26.57, and that gives us x equals 153.43 plus k times 180. Because this is our final solution within quadrant 2, don't forget to put k an element of integers. That just means that for whatever rotation or whatever number of rotations, that rotation has to be an integer. You can't have half a rotation. You have to have a solid rotation. 1 rotation, 2 rotation, 3 rotation, okay? Now, let's move this slightly up. Now, in quadrant 4, we are now dealing with quadrant 4. So we ask ourselves the same thing as before. What is our reduction formula in quadrant 4? Our reduction formula is 360 minus our reference angle, And don't forget to put plus k times the period, which is 180. From here, we now substitute that reference angle. So 360 minus 26,57 plus k times 180. From here, we put this into our calculator. So 360 minus 26.57, and that gives us 333,43 plus k times 180, whereby k is an element of integers. If you had, for whatever particular reason, x plus 10 as your angle, at the end, once you've simplified the right-hand side as far as possible, you move that 10 to the other side, making it minus 10, okay? And then a different representation, if you had, let's say, for example, 2x. So those that attended the grade 11 session this morning, you saw when we were dealing with general solution, we had a value of 2x, okay? So once you've simplified the right-hand side as far as possible, you then divide both sides by 2 in order to get x only. So you would divide this by 2, divide this by 2, therefore making it k times 90, not k times 180, okay? So you can end up with different general solutions. Always remember that your normal equation rules still apply. What you do in a normal algebraic equation, you do here as well. The only difference is that you need to first use your cost diagram to identify which quadrants your solutions are going to be. Because tan was equal to a negative value, we are now using the quadrants whereby tan is negative. So I'll do a recap once more for those that are a bit stuck or are not quite sure of what we did. First of all, we had tan x equals -1/2. We now needed to figure out, okay, because we have tan x equals to a negative value, what quadrants is tan x going to be negative in? We know that tan x is negative in quadrant 2 and quadrant 4. That is why our answers are within quadrant 2 and quadrant 4. From there, once we identified which quadrants they were in order for us to simplify, we needed to first get our reference angle. In order for you to get your reference angle, you simplify the equation. Tan x equals -1/2. Take tan to the other side, thereby creating tan of inverse of 1/2. Keep that in mind, 1/2, not -1/2. Why is that? It is because we do not want a negative reference angle. We only want a positive reference angle. Therefore, if we end up with negative, ignore it when you are doing the reference angle part. Keep that in mind, okay? From there, we needed to then obtain our reduction formula. If you do not know your cost diagram, you would not have been able to get your reduction formula. Therefore, you can just stop there. You can't continue any further. You're stuck. So do you see why it is so extremely important for you to have your cost diagram memorized? If you memorized your cost diagram, you would have been able to obtain your reduction formula for quadrant 2 and quadrant 4 and then simplify. So for the left hand side, that is our solution. Don't forget, we still have a right hand side. Our question is not complete as yet, okay? So let us move over to the right hand side and try to complete this. Okay, so let's have a look. We are now dealing with 3 sine 2x. Now, because this is a general solution, I'm not going to break it up into its identity. Reason being is that I don't want to have both sine and cos. It makes life complicated when you're dealing with two different identities. So to keep life simple, I'm going to leave it as sine 2x, okay? But if this was a simplifying question or a proving question, I would then substitute sine 2x into its proper identity, which is 2 sine x cos x, okay? But because it's general solution, I'm going to leave it like that. So let's simplify this equation. From here, we can get sine of 2x equals, we take -1 from the left, move it over to the right, it becomes +1. We can then divide both sides by 3, therefore giving us sine x equals +1/3. Now this is slightly different to what we did previously. In the previous side, or on the left side, we ended up with a negative value. Here we have a positive value. So we now need to ask ourselves, which quadrant is sine going to be positive in? And that is quadrant 1 and quadrant 2, which means our answers are going to be in quadrant 1 and quadrant 2. Let's leave a bit of space because we're going to end up dividing by 2 because we have 2x. So now that we've identified which quadrants our answers are going to be in, let us now try to obtain our reference angle. So in order for us to get our reference angle, all we now need to do is move that sine over to the other side, making it 2x equals sine inverse of 1/3. From here, our reference angle is therefore equal to, let us see, on your calculator, press shift, press sine, press 1/3, and press equals. Yes, buddy, what's up? Yes, the person that was trying to speak.
Sir, can I please ask, is it necessary that we find the answers for quadrant 1 and quadrant 2?
Like when you say necessary, do you want to like leave it out and just stop there? Or
No, I mean find the answer for quadrant 1 just alone.
oh, like if you only got quadrant 1, you didn't get quadrant 2.
Yes.
Then you won't get all the marks. So you'd only get the marks for quadrant 1. It's kind of like if you were solving for x and you ended up with x equals 2 or x equals 5, and you only wrote x equals 2, you only get half the marks. So you won't get the full amount of marks. So you're already doing the question. Why not just finish it up and get all your marks, right?
Okay.
Okay, then there's a few hands that are up. Gugu, Njabulo, Spilangenkosi, and 111134. You've got your hands up. What's going on? Do you guys have questions? Is there something I need to address?
Yes, sir.
Yes, buddy, what's up?
Yes, I want to ask that why we divide by them cos at the beginning of this.
Oh, at the beginning. Okay, so let me move over to the left side. So for those that did not hear, the question was, why did we divide by cos in the beginning? The reason is because I've got sine and I've got cos. Why must I make my life complicated and have both of them? Can't I just turn it into one thing and deal with one thing only? Why must I now deal with sine and with cos? So to solve that, we divided both sides by cos, therefore giving us tan. Okay, so the whole reason that we divided by cos was to be able to get to tan. We only wanted to deal with one thing. That is also the reason why I did not change sine 2x into 2 sine x cos x, is because I only wanted to deal with one identity. It's kind of like driving two cars. Can you be in two different vehicles at the same time? You can't, right? So drive one car only. Let's drive tan x in that part. Let's drive sine 2x in that part. Let's not make life complicated, right? Okay, then I saw there was a few other hands that were up. Okay, so someone is asking if tan x was 1/2, we were going to find the solutions in the first and third quadrants. Yes, Kaylee, that is correct. If always ask yourself, okay, is my identity equal to something positive or is it equal to something negative? If it's equal to something positive, you ask yourself, okay, which quadrants is this identity positive in? If it's negative, you then ask yourself, which quadrants is this negative in? So 90% of the time, you're going to be asking yourself these questions, talking to yourself, trying to figure it out, okay? That's the whole goal. If you need to talk to yourself, do what you need to, as long as you get the answer. Okay, then why is x plus 26.56 instead of minus? Okay, Kimberly, keep in mind that we said we do not want a negative reference angle. It makes life complicated. So always keep your reference angle as a positive, okay? Okay, so I think that was the last one. So let us move on. We were busy with question 5.3. So it's already 7. I think this will be our last question for tonight before we end. So we are busy with question 5.3. Just a quick recap for those that got lost along the way. We are dealing with the right-hand side, which is 3 sine 2x minus 1 equals to 0. So first we need to simplify for sine 2x so that we can identify whether or not sine 2x is equal to something positive or it's equal to something negative. Now we've simplified it and we ended up with sine 2x equals a positive value. That's positive 1/3. Based on that, we now know that our answer needs to be within quadrant 1 and quadrant 2 because those are the quadrants whereby sine is positive. Now, that's the first part. Let us deal with the second part. We now need to get a reference angle. So in order to get a reference angle, we move sine to the other side and we get sine inverse of 1/3. And that gives us 19.47. Something important, please do not go and divide that reference angle by 2. Don't say 19.47 divided by 2, okay? Whatever angle you are dealing with, carry that angle into your quadrants. So here you are dealing with 2x, carry that 2x into your quadrants. If you were dealing with 2x plus 10, carry it into your quadrants. This is not 2x minus 1, by the way, okay? If it was 2x minus 1, it would be in brackets. For example, it would look like this. And then minus 1 equals 0. Or if it was supposed to be minus 10 or whatever it is. So whatever is within that bracket, whatever is attached to your identity, that is your angle. Keep it as a whole when you move into your quadrants. Do not divide your reference angle by 2. Do not subtract anything from your reference angle. Keep it as is. All you do is move sine, cos, or tan to the other side and get an answer. Don't do anything beyond that, okay? Just stop there. That's your reference angle. Now, from there, we bring down our angle. We know that our angle is 2x. Equate it to the reduction formula within quadrant 1. The reduction formula in quadrant 1 is just theta or just angle. And don't forget to say plus k times the period. We are dealing with sine, therefore our period is going to be k times 360. Okay. Now, from here, we need to substitute our reference angle in place of that L, in place of that angle symbol, okay? So let's see, we've got 2x equals 19,27 plus k times 360. From here, we can now divide both sides by 2. The reason that we are going to divide both sides by 2 is because on the left we've got a 2 in front of the x and we only want x, and on the right we've simplified as far as possible. I saw there was a few hands that went up. Just keep your hands up. I will address you after we're done with quadrant 1, okay? Now I'll repeat that once more. Because we've simplified the left-hand side as far as possible, we can now divide by 2 on both sides. So if you have anything other than your angle on the left, save it, keep it for the last step. That step whereby you've simplified the right-hand side as far as possible, you can't simplify any further, then you divide by on both sides, or then you subtract or add or whatever you need to do from the left-hand side to move to the right-hand side, okay? Now keep in mind, as I've mentioned previously, the period of tan is 180. That is why we used k times 180 on the left. The period of sine and cos is 360. That is why we are using 360 on the right. So from here, I'm going to divide by 2, divide this whole side by 2, and I therefore end up with x equals, now we divide 19.42 by 2, and that gives us, yes.
So your reference angle is supposed to be 19,47.
47. Okay,
Yeah.
let me double check quickly. Sine inverse of 1/3. Oh, yes. Why did I write 27? Okay, thank you for that. Sorry about that, guys. Please note it is 47, not 27. So let us change that quickly. So 47, not 27. So we are going to now divide 19.47 by 2, and that gives us 9,74. Plus, so we've only divided the numerical value. We still need to divide that k times 360, okay? Because keep in mind, we are dividing the whole of the right-hand side. Not only one part, the whole of the right-hand side. So divide k times 360 by 2, you end up with k times 180. And because it's our final answer for this particular quadrant, don't forget to put k an element of integers, okay? So let us move on. That is quadrant 1. Let us deal with quadrant 2. We know that our reduction formula within quadrant 2 is 180 minus an angle, and don't forget to put plus k times 360. From here, we substitute our reference angle in place of that angle symbol, and that is going to be minus 19,47 plus k times 360. So keep in mind, we are not dividing by 2 just yet. We need to simplify the right-hand side as far as possible before we can divide by 2, or before we can do anything with the left. Now, because we've simplified the right-hand side as far as possible, we can now divide both sides by 2. So we're going to say divide by 2 and divide this whole side by 2, therefore giving us x equals, so 160 divided by 2, just give me a second to put that on my calculator. So divide that by 2, and we have 80.27. Plus, don't forget to divide k times 360 by 2, giving you k times 180. And because this is the final answer for this particular quadrant, don't forget to put k an element of integers. 5, okay, so Kimberly, on 160.57, it's supposed to be 160.53. Okay, let's go double check. Our reference angle, let's find our reference angle again. So we'll say sine inverse of 1/3. That is 19.47, so that is fine. Then we'll say 180 minus that reference angle. That gives me 160.52. Or sorry, 53. Okay, yes. Thank you, Kimberly. That is supposed to be 53, not 57. Okay. So we'll get rid of this quickly. This is supposed to be 5, 5.3, not 5.7, okay? Thank you, Kimberly, for pointing that out. Yeah. So this is now going to be 5.3, and